Okay, students, this is the homework help video for Unit 3, Lesson A. Remember, you should only be watching this video after you've put a solid 20 minutes of individual effort, which means you need to work through this list and ask yourself what you can do when you don't know what to do. It's really important you learn to invest effort before you get help. After you've invested 20 minutes of effort, if you still need help, you should be watching this video, taking a look at this page 7 and 8, problem number 5. You're told that all of these are similar to begin with. So if they are similar, it means you have congruent angles and ratios equal. If you have equal ratios, it means for all of these, you can turn them into some sort of a proportion. Ratios equal means all three of these at some point are going to be turned into a proportion. So all you have to do is match up the sides in order to find the appropriate proportion. For example, this first one we have 2 and its match is going to be 4. And what I like to do is I like to circle and then draw an arrow to the direction that I go, 2 over 4. And it's important that you follow that same direction the second time around. So if I start left to right, I end left to right. 6 over x. Cross multiply and solve. B, follow the same process. Now C, there's a problem because we have 3 and there's no match there. And if we come here to this x, we end up with 2 different variables. So you have to look at what else you have and what else you can do. We see here another piece of information. Our perimeter is 60. I'd like you to trace that with me, please. So walk it all the way around. All the way around. That is 60 units. So again, don't ask yourself what should you do to solve for that. What else can you do? And since we have perimeter, let's at least write the perimeter equation out. Perimeter equals 2 lengths, so there would be a length and there would be a length, plus 2 widths. And this unknown is going to be one of the widths, which we don't know at the moment. So let's look at what we can do here. Well, if this length is 21, that means this length must also be 21. So I can plug this in, and I'm going to get perimeter is 60 equals 2 lengths, which is 21, plus 2 widths, which I don't know. Now you're down to one variable. You can use that to solve for your width, but remember that's not your ultimate goal. Your ultimate goal then, once you've solved for that width, is to solve for x, which is going to utilize this proportion over here on the left. It says the president, vice president, and financial officer of a company divide the profits in a ratio of 4 to 3 to 2 ratio. If the company made $1,800,000 last year, how much did each person receive? Proportions are less intimidating if you just think of them as portions. So think of it this way. The president got 4 portions of something. We don't know what those portions are. And the vice president got 3 portions of something. Again, we don't know what those portions are. And then last, the financial officer, so chief financial officer, gets 2 portions of something. So we have four portions of something, 3 portions of something, and 2 portions of something that sum 180 degrees. That should be a big hint together. Together, sum 1,800,000. Use that information to solve for the portions and to solve for the prices. 6, it says draw the following image and then triangle after dilation center at the origin. And you're going to do that by a scale factor of 3/5. The first thing you want to do is simply establish coordinates here. So I'm going to do this A, and A is 1, 2, 3, 4 over 5 and up 10. So we're going to label this one A, 5 and 10. And B is over 5 and up 5. This is B. So B is 5 and 5. And C is at 10 and 5. And you want to dilate by 3/5. That means you're going to take each coordinate and you're going to times by 3/5. So let's just do the 5 and the 10, and the rest you'll have to do on your own. So we're going to take 5 and times by 3/5, and 10 and times by 3/5. Make this really large here so it's easy to see. Okay, watch how this works. Draw exactly these out. Okay, ready? 5 goes into 5 one time. So I take that 1 and I times by 3. 1 times 3 is going to get me 3. So that 5 times 3/5 is 3. Let's do this one. 5 goes into 10 twice. And now I do the 2 times the 3. And of course that's going to be 6. So my new sub A coordinate is going to be 3, 6 after dilating by 3/5. So I go over 3 and up to 6, and that's my new subcoordinate A, sub A, 3, 6. You find the coordinate B and the subcoordinate B by timesing that by 3/5. Here's C, subcoordinate C, plot all three. And because this is less than 1, we know that we are shrinking. Okay, it says in the grid, what would be the equation, the y equals mx plus b of AB? So let's write this out. Y equals mx plus b. We only need two things. We need a b and we need a slope. The b is the y-intercept, and of course the slope is rise over run. So if you come over here, your b is right here. So you already have your b. And your rise, you simply bunny hop. There's your rise. And there's your run. But watch it, careful, it is a negative line. So your rise over your run needs to be a negative line. It is a negative slope. Use that. Bunny hop that. You got your rise and the run, and you already have your intercept. Do your equation. This one says bunny hop A to C and C to B. So AC, you simply, again, find the distance, 1, 2, 3. And then BC, you go this way. And then we want to find the area of the triangle, the area. And it's a right triangle, so you want to write your equation out for area of a triangle, which is simply of a right triangle specifically, which is leg times leg over 2. Use that information to find your area. Last thing you want to do is we want to use the distance equation and find the length of A to B. So let's get our coordinates here. A is at 0, 4. And B is at 5, 0. So we have here 0, 4, and we have 5, 0. You take this information, we're going to make a template. Always make a template when you're doing the distance equation, which looks like this. And then you want to take, we're going to put our x's, so plunk your x's right where they belong. And then your y's right where they belong. And you want to find the distance. If it's a decimal, round it to the tenths place. After you find that length, you want to find the perimeter all the way around.